Alright, so for the kids who are joining for the first time, you don't have to worry about taking notes when I'm teaching it. Okay? Keep your bag separate, take your notebook and pencil out, only for doing some problems when we do in the class. Look, come on in. Find a place, Everybody. Tasvik, move.
No, I'm not sitting in the middle.
Okay. Find a place, otherwise find a chair, whatever it be the case. So a couple of announcements. So for the kids who are joining for the first time, like Vivan, in the class you don't have to worry about taking notes because the iPad is taking notes for you. Meaning I'm recording myself, you can watch the video later on YouTube. This video only goes for you guys. So don't have to worry about taking notes or forgetting about any notes. And for the kids, tomorrow we have the test. Test is, again, Arav is stressed out. I don't know why. Because my goal is not to get anybody stressed out. There will be no result given to anybody. While you guys will be writing the test, it is an evaluation of me and my teaching. Meaning when I go through the test paper, I will be able to figure out what are the areas, the topics that we have in the test that my kids are not comfortable about or not clear about. I will emphasize or redo those things. Like for Tasvik, he has come to this class recently. So there will be a lot of things new for him. So that will give me insight into what are the things that I want to do it again to make sure that all the kids are comfortable with those topics or the concepts. Okay? That's the idea. Nobody gets the score, nobody gets the first prize, nobody gets the last prize. It's only the teacher who gets evaluated when you guys write your test. Okay? So kids who can come here in person, I would suggest you all to be here in person. The test will not happen in this hot garage. It will happen upstairs where we have a better AC. So don't worry about the heat. You will be quietly sitting down and doing the test. Okay? Kids who cannot come in person, they don't have a choice but to do it online. But when you are doing the test online, I want to see your face all the time. So keep your videos on always. Okay? Whoever is doing it online, they'll have to keep their videos on. Okay? Alright? So let's get started. This was the initial jump start. Aryahi. Okay, you guys, one of you can create some space. Tasvik, why did you come here? So you're not the odd one out, neither Aryahi is the odd one out. Okay? Alright. So, what are we going to do today? That remains $1 million question. Tomorrow we have a test. And the good news is, nobody has to prepare for the test. I don't want anybody to prepare for the test. Because, see, what we are learning is called life skill. Math is part of life. Do I go with my notebook to Target or to Walmart to find out how much money I have to spend for buying things? Do I carry my laptop with me to find out the percentages? No, that's a life skill. So, whatever I teach you guys, do you think I memorize it? No. I just look at what are the topics for today and then I cook it up on the fly. And I want you guys to get the same skill. So let's look at what we are going to do today. Right now, Dikshita is thinking what is coming our way, isn't it? Tanu is also equally perplexed, thinking what is there for us today. Let me open it up. Alright, let me go to the topics that I have picked up for you guys. I am actually very forgetful. I keep forgetting things. Okay, we are going to talk about the concepts around similarity. So we'll start with what is scaling and then we look at some problems to interpret that, and scaling or similarity becomes the base for us to deal with a lot of interesting theorems around geometry in future. So, and if you guys are familiar with similarity, why don't you give it a shot and explain me, or teach your teacher what is your understanding of similarity or scaling? Any thoughts? What is similarity? Yes, Arab. Give me a simple answer, okay? Knowing a teacher is not very intelligent.
Oh, similarity could just be like, number over it. Now, find it to be thick or congruent. Could be another mathematical vocabulary.
I told you your teacher is not very intelligent. You're still assuming that. Give me a very simple definition of what is your understanding of similarity. Let's see what Nihan says. I'm sorry?
So similarity is like numbers that are identical or have the same roots.
Okay. So I have 6 kids in the classroom and all of you on the screen. Do you think anybody looks similar to me? No, right? Why? How did you come to that conclusion so quickly? I mean, argue with me. I want to hear your point of view. Yeah?
Because no one is really a different person.
No, all of us are different. Everybody is different. This is triangle, this is also triangle. I'm a human being, you guys are all human beings. I'm asking, is there anybody in the class who is similar to me? Why?
Because you're older.
No, I know you guys are not born at the same time when I was born. I was born in 76. Nobody was born in 76 for sure. So, keep that thing out of equation. Any other, no, see, nothing bad. We are just trying to find out the basic concept around it. Look at this. What is the difference between same and similar?
Similar is like when they have like some qualities that it like match and then same is like exact copy.
Exactly, that's a good starting point. When you say same, if I say who is same as me, you will say give this question to somebody else. Nobody in the classroom. Right? It's very difficult, right? I mean, among 6 billion people, if you try finding somebody who's your lookalike, probably there'll be only 6 people on the whole earth. I mean, that's one theory. Let's not go there. What I'm saying is, same means when okay, now let's come back to a serious business here. All that nonsensical examples that I was giving, let's keep it aside. Now, let's say we're talking about 2 objects. If I say these 2 are same, that is when it relates to the concept of congruence. When you say 2 things are same, there's one extra word, extra word that you can use. You can say they are same or you can say they are congruent. One extra word in your vocabulary. Same and congruent are the same. They mean the same thing, exact copy of each other, meaning wise. Now, when I'm saying this and this are same, that means each and every property of these 2 are matching. That is why when I asked you guys a question, who is same as me in the class? You guys said each and every person in the class has more hair than me. That was one disconnect that you immediately found. Say, okay, fine. Same, everything has to match. At least there is one criteria that doesn't match. Done. Out of discussion. So when you're talking about same, you are saying each and every property are matching. Okay? So whether you call it same, whether you call it congruent, it has the exact same meaning. No doubt anybody has, right, about same. And Arab, I never discourage you to give your point of view, but I was saying that give me a very lame example that a child who is 5-year-old can understand. That's why I'm giving you guys all the examples so that it stays with you, okay? I'm not going to dare to compare any of you with me, okay? I don't want you guys to grow old that fast. be like a child for 2 more decades. That's okay. Alright, so here, when you say same, meaning in case of geometry, when you say two objects are same, each and every property are matching. Meaning this side and this side matches. This side and this side are matching. This side and this side are matching. This side are matching. And then this are also matching. And if this is 1, this is also 1. If this is 2, this is also 2. This is 3, this is also 3. This is 4, this is also 4. Then you say they are exactly same. Every property is matching, right? That's why when you guys were comparing yourself with me, you said, okay, fine. You are old, I'm young. You have less hair, I have more hair. You are only this high, this tall, I am this tall. Right? You wear glasses, I don't wear glasses. Those were the criteria, those were the properties. That is how you define me and define yourself, and then you compare. So when you are talking about the geometrical objects, for them to be same or congruent, you match every property. And when all the properties match, you said they are congruent or exactly the same. Make sense? Everybody? Now, this teacher is misleading. We were talking about similar and I am talking about same. No, I'm not misleading. I'm trying to relate things. So same, there's no doubt. Now look at, let's play with the phone that we enjoy the most. Let's say I have a picture here. Look at this picture. What am I doing? Zooming in, zooming out?
Yeah.
Can you guys see what I'm doing? I'm just playing with my phone. I enjoy playing with the phone. I'm zooming in, zooming out. If you look at this triangle, that small green one, when I zoomed in, it became big. When I zoomed out, it became small. But did the triangle transform into a rectangle by any chance? It did not. That is what is called similarity. Zoom in, zoom out is the most practical scenario of similarity that we talk about. Now let's decode it further. This is your triangle. You zoomed in. Became bigger. So sides are of different length. This side became this big. This side became this big. This side became this big. But they still look somewhat similar. It did not, when you zoomed in, it did not become like this. Yeah? They look similar, not the same. Why similar? Similar is an English word. It says somewhat close, some properties matching, like you guys said. What are those some properties? These angles are the same property. If this was 1, this is also 1. If this was 2, this remained 2. If this was 3, this remained 3. The angles did not change. The edges did not change. The sides changed. So when you are zooming in, you are making it a bigger scale without changing the angle. When you are zooming out, you are scaling it down. When you zoom out this one, it will become like this. Your angles are still the same. Your side's length is shrinking, becoming small. So here you are scaling down, here you are scaling up. So similarity is a concept where you scale in or scale out something to make it look zoom in or zoom out. So zoom in, zoom out came in from the scale up, scale down concept only. Okay. So now you look at your face, or take a picture of yourself on the phone and then zoom in, zoom out. Your face will not change. You will not become from a normal person to a superstar. You will remain the same person. Looks the same, but smaller view versus bigger view. Okay. Again, no, I'm not saying that we don't, or you guys don't look like superstars. Everybody looks superstar in their own world. And you want it to be that way, no question about it. But what I'm saying is, similarity is a concept where if you relate that with the geometry, you will see that the angles, the edges don't change. It's only the scaling up or scaling down of things that happens. Is that okay? Is that relatable? Arav, Nihan, Advik, Sanvita, Gayatri, everybody? Diksha? Not Diksha, Dikshita. Diksha was in the previous class. Okay? Gitesh, clear so far? Are these lame examples working out? Okay, see. Abhiram saying yes. Lame examples are good. Okay, so similarity, so if you have to ever compare between similarity and congruence or same, you will say similarity means a situation when some of the properties match. Congruence means when every property matches. Meaning it's a Xerox, it's a copy of each other. Okay? And similarity, only the angles are matching. Now let's look at it. Now let's look at the detail of it. What did I do? Let's say this was a triangle ABC with length 5, 4, 4 and 8. I zoomed in. It became a different looking triangle. Let's say DEF. I zoomed in. What did I do? I scaled it out. Yeah? I scaled it out, meaning I made it bigger. When I say scale it up, not out. Scale it out, scale it up. I zoomed in, made it bigger. You would have seen the camera like 1.5x camera. What does it mean? It can zoom in by 1.5 times. So you can see the picture from 1 meter, from 1.5 meters it will look like as 1 meter, or it gives you 1.5 times view of the regular camera. Okay? Yeah, sure. Take the responsibility of closing it. Somebody to go and close the garage. The switch above. Yeah. Thank you. So scaling up and scaling down are the two babies of similarity. Okay? Now let's look at some real problem, and then you're going to relate to what we have learned and how does it actually help. Let's look at a problem. And before we try doing that, let's look at one more concept about finding the corresponding point. Let's say this is a triangle. Let me make it look a little different. Okay? So, if you have, let's say, these two triangles, if I say these two triangles are similar, what does it mean? Right. Essentially, the angles are same. Yep, yeah, Gayatri. Go ahead.
I was just about to say a few of their properties are similar.
Some of the properties are same, but to keep it more precise, you will always say angles are same. Now, look at this triangle and this triangle. Even if they are similar, that means for every angle, there is a corresponding matching angle here. And that corresponding matching angle derives your corresponding points. Let's say this angle is 60 degrees. If you look at this picture and assume these two are similar, which angle, let's say this is A, B and C, and this is D, E and F. So wherever you have, so when we say these are similar, that means they are angles that are matching. If this is 60 and let's say this is 60, if this is 30, this is 30, this is 90 and this is 90. So these 2 points are called corresponding points. Even if this triangle is flipped upside down, but these two are called corresponding points, meaning the points where the angles are matching. You'll always relate to them as your corresponding point. And that plays a very important role in the concept of similarity. And we'll look at that. That will make it more clear. So, when we are talking about, so two concepts here. One is, when you are talking about two shapes being similar, that means you are saying the angles are matching. Meaning for every angle there is a corresponding matching angle. And those matching angles, these points where those angles are made are called corresponding points. Okay? Now, all that I was saying is the concept relating to zoom in, zoom out, scale up, scale down, and together it's called similarity. Now let's look at some problems that you guys will end up dealing with to see whatever we have discussed so far, is that of any use or not? Let's see. I have figure A and the question is, if you look at this figure and this figure, do you think they are a scaled up or scaled down copy of each other? Why? Anybody have a different point of view? Sandri, do you think these two are scaled copy of each other, scaled up or scaled down copy of each other? Aryani, any idea? Okay. Deekshita, Gayatri, are you guys able to see the board clearly first? I have my doubts in place. Can you guys see the board okay?
Yes.
Okay, so Tanu, Myra, Deekshita, Gayatri, Samvita, anybody, tell me if these two drawings look scaled up or scaled down copy of each other, or they look similar to by any means. Do they look similar by any means? Myra says no. Okay. Okay. I got so many thumbs down. I said, does it look similar? And I got thumbs down. No. So I'll say no, they are not similar. Because for similarity, your first criteria is your angles have to match. Don't see, there's not much information given in this question. But by the picture itself, you can see this angle and this angle don't look to be same by any means. Yeah? One angle has not matched already. Even if this is 90, this is 90, this is 90, this is 90. But look at this angle and this angle. This is a much smaller angle compared to this one. Yeah? So when the angles don't match, they are not similar. That's the first criteria for us to figure out. Now, let's look at a little more serious problem. We have two shapes. This is 9, 7.3. This is 7.3. And this is 9. And then I have a shape here. 3, 3, 2.2 and 2.2. Do you guys think it is similar?
No.
No. What is the hurry? Think about it. First think about it. There is hurry only when there is a nature's call. You cannot control it. But when you have a problem to solve, my most annoying method. Read, analyze, and then do it. And once you have done it, then you answer it. Now I don't know if I want to change Ran to Rana for now, but yeah. Yeah.
I said it kind of similar because the answer was on the one for the given was say 9. If you like scale it down by 3, you get to be a smaller by 3.
Right.
So I said kind of similar.
Okay. Yes, Gayatri. I think I got one good answer. Let's hear some more. Yes. Yes, Gayatri.
I was going to say something along those lines. Like, they might have some similarities.
Okay.
One just looks like the scaled down version of the other.
Exactly. So now scale down, scale up. That we'll deal with. So first thing was the visual part of it. Based on the intuitive guidance, we were saying that okay, whether they are similar or not, just by looking at the angle. Which one is okay? If the angles are matching, then they are similar. Okay, fine. Now there comes the next concept that okay, if you have two things similar, then so before we go to the math, okay, I was saying this is our method, right? RAN, read, analyze, and then write it, do it. And once you have done it, then you get the answer. That Ran became Rana. I don't want to do that. That looks funny. So I don't want to add that to the concept. We'll stick till Ran, okay? Or do you want me to change to Rana? Rana looks funny. Let's not do that. Okay. Alright, so now let's look at this. These two are similar, okay? These two triangles are similar, meaning this angle and this angle are matching. This angle and this angle are matching. This angle and this angle are matching. This becomes our primary criteria for saying that these two are similar. Meaning this is a zoomed in version of this guy or this is a zoomed out version of this guy. Now, with this concept, the scale up, scale down that we were talking about, you will say, okay, this is a scaled down version of this guy. Or this is a scaled up version of this guy. Now let's see what is the scaled up, scaled down. From where that scale comes into picture. You see some scale here, 1 centimeter, 2 centimeter, 3 centimeter written here. Or the angles here. So there is some scale, something getting measured. How do we measure it here? How much scale up, scale down we are talking about? Now let's look at it. So similarity says, if you have two things similar, then their sides will be in the same proportion. Meaning, if let's say this is 9, this is 3, let's not do that. A, B, C. Or you can put it this way. Side upper to 1 is A, side upper to 2 is B, and side upper to 3 is C. And here, this is let's say D, side upper to 2 is E, side upper to 3 is F. So from this, if you look at these two triangles are similar, then their sides will be in the same proportion, meaning both the matching angles, the ratio of the side, A over D. This will be same as pick the second matching angle, these two. What is the side upper to this? Side upper to this is B over E. Look at the third matching angle. Side upper to this is C and side upper to this is F. This is the third thing that comes into the picture. If the two shapes are similar. Now A over D, let's say this length was 9 and this length was 3. So A over D is 9 over 3, which is 3. It is scaled down 3 times by 3 by ratio 3. Likewise, if you say if you keep it D, and this is D over A is scaled up by D over A. So D is 3 and this is 9. D over is 1 by 3. So this is scaled up. D is scaled up. This is how you say A equals 3D. So D is scaled down by 3 by factor 3 to A is scaled down by factor 3 to get a D, or D is scaled up by factor 3 to get a A. That is how you relate it. Okay. So basically, summary of this thing is, if there are two shapes similar, their sides are in the same proportion, you will look at the matching angles in the side opposite to that, and the ratio will match. So if this side to this side is less, means it is scaled down. If this side to this side is more, that means it is scaled up. Yeah. So let's look at one more problem. I think then you're going to relate to this one. But is this concept understandable, or I am getting you guys more confused? So far okay? Let's look at one problem here, and then that will give me an indication of whether I am teaching you guys okay or I am getting you guys more confused. I have two pictures here. Okay. This is picture A, this is picture B. This is 18, 11, 10. This is 72, 44 and 40. The question here is, figure B is a scaled copy of figure A. Okay? And you have the values given 11, 18, 11, 10, 72, 44, 40. It says, what is the scale factor from figure A to figure B? Yeah. Okay. Do you guys agree with what Vivan is saying? Sanvi and Aradhya? Adya. Are you guys agreeing to what Vivan said? Vivan said that the question was that this is the numbers, these are the numbers given for the side, length of the sides, for this and this. It says B is a scale copy of A. So it says find out the factor, find out the scale factor from figure A to figure B. And Vivan said 4. Do you guys agree? Sanvita agrees. Deekshita, Suhina agrees. Scale factor of 4. You agree? I saw it with a very firm standpoint. So that's good. I'll come to you guys to understand why 4. Okay? Everybody has understood, agreed? Vasundhara, Saurya. Okay. Yeah, Gitesh, you have raised your hand.
Scale factor of 4.
Scale factor of 4. Yeah. So that's what Vivan said also. I was just checking if everybody is agreeing to that. So Sanvita, Vasundhara and Saranya, not Saranya, Thanu. Do you guys agree? Thanu, do you have a way to change your name, beta? Otherwise I'll keep on getting confused and keep calling you out by bad name. I mean wrong name rather.
I tried to change it to
Not right now, maybe later.
Okay.
Okay, now let's look at another problem. I have this is one triangle and this is second triangle. I am saying it's a scaled down copy of, so this is figure A and this is figure B. B is a scaled down copy of A. And the sides length here are 18, 15 and 28. And I know this side is 9. Can you guys tell me this side and this side? Real quick. Okay, Arnav. Yeah, go ahead. I'll come to you guys. Keep it ready, Indian. Yeah, Arnav.
So,
Just tell me the answer. You don't have to explain it right now. I don't want anybody to get biased by your answer. Just tell the answer.
actually, the definition is going to my mind.
I'm sorry?
So, definition is going to be the woman is created as proportional.
So tell me what is this one?
Yeah, that one's good.
14. How about this guy?
This one is 7.5.
Okay. Anybody else? Advik, is your answer matching with what Arnav said?
Yes.
Okay. Gayatri,
I got the same thing.
same answer. You guys also got the same answer? Same answer? Sure? Aryahi, Myra? Okay. Shaurya?
Yeah, I have to say that.
Same answer. Okay. Now, so here, same thing is, these are similar triangles, and just by looking at the pictures you could make out. Now, okay, cool. Now let me try making your life a little more complicated. And don't go by the optics. What it means is, what you see on the board, it might look bad, courtesy my drawing skills, but rely more on the values. Okay. So let's say I'm giving you values as now I have two triangles. I am calling them similar. So this is 95 degree, 43 degree, 42 degree, and the sides are 7, 1 minute. Let me complete it. Okay. Yeah. And the sides are 7.5, 8 and 14. Here I have a similar triangle, 95 degree, 42 degree, 43 degree. And this side is 7. I want you guys to find out this length and this length. And yeah. So these two triangles are similar. This is 95, this is 95, this is 43, this is 43, this is 42, this is 42. This length is 14, this length is 7. I want you guys to find out these two levels. Do something with the pen and paper. You bought them. Use it. How will you solve it then? If you don't use pen and paper, how will you try solving it? It's a little trick question, and that trick question has one element of information to be confirmed. Adam, stop laughing, stop throwing those emojis, that is of no use. Yep.
So the bottom one is 4, and that one's 3.75.
Okay. How about you? Are you same? Gitesh?
For AB I got 7.5, and then for BC I got 8. I mean
I want these two.
I got 3.75 and for DC I got 2.
I mean something equivalent to this one here, we are saying 4, okay? How about Nihan?
I got the same answer.
How about Adam?
Yeah, I said the same.
Okay. How about Arihan?
Yeah, I got the same answer.
Dikshita?
Got the same thing same.
Myra?
For AB I got 3.5 and for DC I got 4.
I'm sorry, say it again.
For AB I got 3.5 and for DC I got
3.5?
Yeah, I got 6.
Okay. You got 3.5 or 3.75?
3.75.
Okay. Anybody else? Vasundhara? Suhina? Saurya? Anybody who got the same answer or different answer?
I got the
Same answer. I'm super excited and happy to say that everybody got wrong answer.
What? Huh?
I'm super happy to say that everybody got the wrong answer.
What? How?
Now you will say why. I said there's a catch here, there's a clue here. Look at this. This angle and this angle are same. So this side and the side.
That's 3.7 and that's 4.
So I had purposefully tricked you guys. You would have seen me manipulating the degrees here. 95, 95. 43, 43. 42, 42. Yeah.
Can we have a bandage?
Yeah. Pen?
Bandage.
Bandit? Oh, what happened? Can you ask Auntie to get? Okay. Lot of problem or little problem? Little problem? Okay. Still get a bandit for you. Okay. So here, the catch is this. You have to always rely on the angles. Otherwise, similarity is one of the easiest concepts to learn. Similarity revolves around angles. Mess with the angle, it will mess with your result. And the reason why I gave this problem, I wanted you guys to do it on purpose because always keep in mind that even if it looks identical, I remember, if you remember, I said don't rely on my drawing skills. Rely on the numbers that you see on the board. The numbers were the clue. Meaning this side and this side will have direct relationship. And this 30, 43. So this side and this side will have direct relationship because they are opposite to the matching angles. So that's a very vital concept in the concept of similarity. You always go by the sides opposite to the matching angle. Is that okay? Are you guys upset that I was happy for you all being wrong?
I was surprised.
Huh?
I was surprised.
Yeah, Gitesh, good.
So
Yeah. So because your guiding principles are your angles. Which two angles are matching? This angle and this angle are matching. The sides opposite that in the same proportion. So this by this. Okay. Now, which other angles are matching? This and this. So side opposite to this is this by this will match to the same ratio. Other two angles, this and this are matching. What are the sides opposite to that? These two. So this has to be 4 if this is 8. This has to be 3.75 if this is 7.5. Okay? Make sense? Don't care about the answer. I don't want you guys to care about the answer. That's why I keep saying. Always focus on the concept part of it. You making a wrong or giving a wrong answer doesn't do any damage. But you getting the concept right is what we are here for. Alright? Okay. So this is on the similarity of triangles. Similarly, tomorrow if you are dealing with similarity of any shape, zoom in, zoom out, or similarity is not limited to only triangles. You can zoom in, zoom out my face as well on the phone, right? When you open up, yeah, and then don't punch. Just zoom in, zoom out. Okay, so coming back to zooming in, zooming out is a concept that applies to any and every shape. Tomorrow, if you come across shape like this,
Wow.
and yeah, and then you have the angles given. I mean, you have some clue which tells you that they are similar. Then it will also follow the same ratio. It is again a scaled up or scaled down version. Okay, so don't consider similarity being limited to only triangles. Similarity applies to triangles, rectangles, or any shape for that matter that we deal with. Any questions? Tanu, Advik, Arav, Nihan, Arihan, anybody? Vasundhara? Now, a quick question for you guys. Who all are going to be here in person for the test? Everybody here? You'll be here in person for the test tomorrow? Yeah. I mean, all the kids who are living nearby, I expect them to be here in person. Kids who are, yes, Sahina.
I'm going to be there for in person.
Wonderful. I would look forward to see you in person. I have seen you enough online. Gayatri, are you going to be in person, beta?
Yes, sir.
Okay. And all the kids who have been doing the class in person, being in the classroom, you know that during summer it gets a little hot. So we'll do the test inside. Okay, so it will not be the temperature that will bother you. Questions might. Okay, we'll see. But the point here is that for the test, I don't want anybody to prepare. I do not want you guys to prepare. I want you guys to come to the class with a very cool head, whatever you know. I'm hoping that whatever we have learned so far, we have not totally forgotten it. We'll try recalling the concepts, apply them, and then solve problems. Yeah.
While I was gone to the class, did you like cover any new topics?
I'm sorry, ma'am?
While I was gone to the class, did you cover any new topics?
Of course, we did cover some topics, but just go through some of the videos and let me know if something is bothering you. Okay? Yep. Yeah, Rav, you have a question.
When it comes to we're not dealing with big tests like last time we did the test.
Uh-huh.
Okay.
So, I mean, somehow, for whatever reason, we have been little irregular with the test. We had just one test and then we kind of stopped it. Now, with you guys growing up, I getting a little older, we'll try being more frequent, more regular with the test, and we will have tests every 6 weeks. And these tests are nothing but more of a a way for us to see whatever we know, how we are applying them, how effectively we are able to solve that in a stipulated time. Because it's not just about solving problems, it's about solving problems in the given time also. Okay? So that's where the practice plays an important role. When you solve the problems in the given time, in a more calculated way, that is what you're going to face in the exams also. So it gives you the ability to prepare and be ready. Yes, Gayatri.
How many questions are you given this tomorrow?
Okay. I have not been answering those questions. Let me see. No, I can just give you guys a quick peek into that. I'm not going to disclose the questions though. What time? Do you get gulab jamun right after reaching home last week?
No.
No? Then why are you waiting for the class to get over so desperately?
It's
So there'll be, it has to be hot, summer has to be hot. No, so you guys are right in front of the AC. Look at, but after the class gets over, I go and change my t-shirt. So that's the only way I can sit next to anybody. Otherwise people say you stink. But then when I'm teaching here, I'm not worried about time. I don't know whether my watch is working right now or not. Not worry about time, I'll not worry about anything else. So that we can focus only on maths. So, Gayatri, to answer your question, or for everybody to be aware, we'll have 15 to 16 problems that we'll try solving in 1 hour's time. So every problem 5 to 6 minutes. And these problems will not be difficult. My only advice to you guys would be, as soon as you get the question, I'll give you guys 5 minutes to go through the question, see which one looks easy, which one looks difficult, how do you put your strategy in place to pick up the ones that you can do quickly. Because that is the kind of strategy you would need in an exam also. Yes, madam. 3:30 to 5. So initial 30 minutes I'm keeping for arranging everything, settling you guys down, giving you guys initial gyan, theory that I share, and then hand over the question paper to you guys and start the stopwatch. Alright?
So you're timing us?
Yeah, 1 hour. I mean, unless you guys want to stay with me, have dinner with me. Yeah? Alright? So with that being said, I'll say best of luck to each one of you and best of luck to myself. I'm hoping that I have been able to successfully teach you guys or explain things to you guys. If you guys struggle with some concepts, that's a red flag for me and for me to redo those concepts so that everybody gets comfortable. And all the kids who are not here in DFW area, who are doing it online, you will join online, you will keep your video on, do it in front of me as if you are doing it in the classroom. That's all. Okay? Alright? So take care, have fun, see you guys tomorrow. Yes, Gitesh.
What was this?